We have a fairly routine looking problem here where we have a quadratic equation with integer coefficients, and we're trying to show that any solution to this quadratic equation with integer coefficients can be represented as a line with linear coefficients. Now let's jump in. It's not. I can't see how this is an interesting problem really in any way. Maybe a lemma for a more difficult problem, but we can carry on here in a fairly straightforward fashion. We're supposed to show that x cubed is equal to mx plus n. It's a linear form with again with integer coefficients. So again, very routine stuff. X cubed by laws of exponents is equal to x to the first, right, times x to the second. But notice we can make a substitution here because our given, and again, you can think of x as a solution. This is not for all x. In other words, this is just a solution. So x squared is equal to ax plus b. All right, it's another way to rewrite that. And of course, that makes it crystal clear that we're going to end up with a double substitution. Notice x squared gets replaced with exactly what it's equal to right here. So if you multiply this out, we come up with another occurrence of x squared, and we substitute again. See, so it's literally a double substitution going on here. And so what is all this going to be equal to? You would have a squared x, right? A squared x, and then you would have plus, looks like bx plus ab. Okay, and so let's see here. Oh, no, sorry. This is, no, yeah, we're good. A squared x plus bx, everything's looking good. And so, folks, we can rewrite this as a squared plus b being the coefficient of x. And then, of course, plus ab, right? So that's what's happening with this. And so you see what we've done, you can, not that you need to see this necessarily, but we were trying to show that x cubed, this is x cubed, right? X cubed is equal to all of this stuff, x cubed is equal to all this stuff. So we're looking for integers m and n such that this is true. So your m is equal to a squared plus b, which is also an integer, and then your n would just be ab. So that completes the proof, folks. Not much going on there. I wouldn't have known this is even true, but if x is a solution to a quadratic in this form, we can write x cubed as in a linear form with integer coefficients. And again, this is not a challenging problem by any stretch, but it's a nice problem in the sense it might serve as a limit to a more challenging problem. You might get to a point where you needed this, but you didn't know that this was a thing. You know, this was true. But anyway. So we proved it, and we're done. So here we go. Let me get that circled. And again, you may want to experiment with, if you got the time, you're really bored, you're in prison or something, and you want to find a solution to a quadratic that looks like this. All right. Then you can check to see if it fits here. You could check to see if you can find this will give you a recipe to find the m and the n such that this likely irrational solution has a representation in a linear form like this. But anyway, I think it's kind of nice, but it's not particularly awe-inspiring. Thank you for viewing.